In this video, I'd like to talk about the math question of the day for Saturday, May 13th, 2023. And with this problem, we need to sketch a graph of a function that satisfies each of the following conditions. And we can see these one-sided limits as x approaches 2 from the left-hand side of our function. This has to equal 1. As x approaches 2 from the right side of our function, this has to equal -4. And when we plug in 2 for our x value into our function, we get an output equal to 1. So we just need to find some function that satisfies these conditions. And frankly, there could be many functions or infinitely many functions that satisfy these conditions. But a question like this will typically come up early in a Calculus 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And we need to sketch a graph. So let's draw in a coordinate plane, just our typical XY axes here. And we are concerned with x values of 2. So that is our key point, though we will have y values of 1 and -4. So let's draw in enough tick marks to include those. And let's start with this defined point. When the x value is equal to 2, the function is equal to 1. So we definitely have a point right there for our function. Now, for these one-sided limits, it's a little bit more complicated, but we're told that when the x value approaches 2 from the left-hand side, from the negative side, that it approaches a y value of 1. So for that to happen, it could come in infinitely different ways. Maybe the function comes in something like this, or maybe it's something like that, or it could even be maybe something like that, as long as it's still a function as it approaches this point. And I drew this a little bit carelessly. We shouldn't have anything that fails the vertical line test, but we'll just assume that this blue line is a function as well. So it could be any of these curves. In fact, it could be infinitely many different curves, as long as the curve approaches an x value of 2, the y value approaches 1. As long as that condition is met, then any of these are possible. Now, for the other side, we're told that as x approaches 2 from the right-hand side, from the positive side, that the y value of our function approaches -4. And -4 is down here. So for this, I'm going to put in a hole for our function, because we know that at an x value of 2, it's defined to be a y value of 1. So it can't also be defined to be a y value of -4, since that would fail the definition of a function. For every x value, there should only be one y value assigned to that. So we'll draw in a hole here, but from this right-hand side, the function can approach this hole in, again, infinitely many different ways. It might be a straight line, or it could be something that's curvy, maybe something like that, or possibly something simpler, maybe like that. It could be any of those choices, or it could be any of an infinite amount of choices. So each of these different colored drawings here represents a possible function that satisfies each of these conditions. Since let's just focus on the green one here. As the x value approaches 2 from the left-hand side, notice that the y value approaches +1. And since we have a filled in point here, we know that when x is 2, the y value is, in fact, equal to 1. So that this condition and this condition are both met with the green curve. And then as x approaches 2 from the right-hand side, along that green curve, notice that the function approaches a y value of -4. So that is met as well. Though, like I mentioned, the function is defined at an x value of 2 to be equal to 1, which is why we need to draw in a hole here, because if we fill this in, then the function fails the vertical line test. Then at this specific x value, it has two different outputs, which will fail the definition of a function. For every input, there can be only one output. So we have a hole here. But for the green curve, and frankly for the blue and pink curves as well, each of these three conditions is met. So with this problem, there's a lot of freedom. There are infinitely many different ways to draw this as long as you meet these conditions.